Hello and welcome to Casio's online course for the new and improved ClassPad. In this second session we will be taking a closer look at basic computation, symbolic algebra using the CAS system, as well as some calculations involving expressions and equations. If you are starting from the icon menu, we'll open main mode by tapping the main icon across the top of the screen. However, also note that main can be accessed from the quick access bar across the bottom of the screen as well. As a reminder, note that the current format is identified across the bottom of the calculator. Currently we're in standard, real, and radian, but if you wanted to change any of those, all you need to do is tap them with your stylus or even your finger to toggle to, in this case, decimal back to standard, real, or complex mode, radian, degree, gradient, and back to radian. We will be spending a little time in the action and interactive menus. You'll notice they look virtually identical, almost exactly the same. The only difference for the most part is that action will expect you to supply the syntax. You need to know how these functions work to use any of them, whereas interactive, if you pick a function, it will give you a nice little prompt that you can fill in the important details. Also, if you are new to the calculator, you should know how to access the keyboard. If you press this key, we get a nice soft keyboard. You'll notice some tabs down the left-hand side. Math 1 tab is the default, and you see a lot of handy things like fractions and square roots, pi, etc. In the Math 2 tab, we have some of the same, but we also add in imaginary numbers, integrals, derivatives, limits, matrices. In Math 3, we have a few other features, some comparative operators, systems of equations, and then we have trig functions, variables. I'll explain those a little more in a minute, and our standard letters, Greek letters, other math symbols. If you get into this part of the keyboard and you're not sure how to get back, it's this little return arrow, which will bring you back to the initial setup. So let's start out by summing 3x plus 5x. I'll close the keyboard for now. 3x plus 5x. Now, if I were to press execute on a standard calculator, standard calculators don't know what x is. All they know when they see a letter like that is that's a variable location. A lot of times those variables will default to 0. Therefore, it would just assume this is 0. 3 times 0 is 0, plus 5 times 0 is also 0. Total answer is 0. It just gives you an output, a numeric result. But with this particular calculator, it knows that x represents a variable. Unless we tell it exactly what x is, it will leave it in variable form. Therefore, when I press execute, we get the result 8x. That is symbolic manipulation. That's the CAS system in a nutshell at its most basic. So now if we were to try 3x squared plus 5x, the calculator is capable of recognizing those are not like terms. It will not combine those. Now there is a neat feature of this calculator. Actually there are several, so I'll try to combine them all into a quick demonstration. One nice thing is if I want to grab this result and I just have to tap on it, and you highlight it, and then just like you might expect on a computer, clicking and dragging or tapping and dragging to the next line will just duplicate it. So if I want to take 3x squared plus 5x, and now let's say I want to evaluate it at some point. We go back into the keyboard, and I don't see what I'm looking for here. Maybe Math 2, Math 3, there we go. This vertical bar. This is the with operator. What it means is to evaluate this function where x equals, we get to choose. Let's say where x equals 5. If I press execute, it now substitutes 5 in there and gives me that evaluation. It's strictly a one-time deal. X has not been altered. There's nothing stored in x at this point. It is simply evaluating that function. If I want to do it again, I can highlight it all and drag it down and then back up and change x to 2 and see what we get. So this is really powerful for investigating numbers, functions, expressions, patterns, etc. Now, in the Action menu under Transformation, one nice feature is Simplify. You'll never know when this will come up. A lot of times the calculator will by default simplify for you, but sometimes in the process, because of the order of internal operations, sometimes you get a result you think can be simplified a little further, and this can be used to accomplish that. So just to give you a quick example, what if I had 15 root 3? Don't forget to move the cursor out from under the root symbol by pressing the right arrow, plus 26, close parentheses, and I will raise that all to the 1/3 power, close parentheses. And so sure enough, it simplified that to root 3 plus 2. That's a good example of something that might not be obvious until you force the calculator to attempt a simplification. Another very handy tool under Action Transformation is Expand. If I were to expand x plus 4 quantity to the 3rd power, it will multiply that all out and give me a nice long polynomial. Closely related to that is factor. There are several factor options. I'm just going to pick the initial factor option. Now there's a couple ways you could factor this previous result. One way is at the bottom of the keypad we have ANS for answer and execute. Not a big surprise. Or I can actually clear that and I can tap and then tap and drag. I'm going to do that again just so you see the process, because this is somewhat important. I first have to tap it once and release to highlight. Then I tap and drag to move it to the next line, and again when I press execute, it will again factor that appropriately. Now what if I want to factor something else? You could go back into the Action menu, but when you become really comfortable with the calculator, sometimes it's easier to tap and highlight and just drag down the word factor. Now let's say I want to factor x squared plus 3. Those of you who are familiar with factoring know that this does not cleanly factor. There are no nice integers in there for me. In fact, I think I'm going to change this to x squared minus 3. Even so, there are still no really nice clean factors. There are irrational factors, but no what we would expect for a typical integer solution. So this is where, under transformation again and factor, this is where our factor comes in. This will go all the way down to any irrational roots if possible. So if I grab this, again tap and release and then tap and drag, now we get x plus root 3 times x minus root 3. That our factor goes just that one extra step if possible. And the last thing I want to show you from the factor menu is factor out. What factor out will do is if I give it something like, bear with me, I'm going to go back to the keyboard under the letters and in the ABC tab, A, x squared plus b x plus c, comma, what do I want to factor out of that expression? Let's say I want to factor out the letter A. Close parentheses. You don't always have to close parentheses. If there's nothing at the end, it will generally just assume you wished to close the parentheses. If we press execute, you'll see that it pulls an A out of each term, whether or not it comes out nicely. So pulling the A out of the ax squared term is pretty easy. Pulling it from b times x, it has no idea if that's doable, so it just divides by A, divides by A. Now, there's a really critical point here that's very important for you to understand. The calculator makes a distinction between these regular letters, denoted in regular font, and if I back up here and go to variable, you see these bolder italicized letters. These are variables, like the x right here is right there. And these are the same as these x, y, and z here. These are all variable keys. The reason these variables are important is this calculator is able to even allow you to use words as variables. And so when it allows you to use words, it doesn't know when you type something like, let me go back here, AX, whoops, I put that in the wrong place. Let me fix that. Put the cursor down here. If I type AX, the computer doesn't know, or the calculator doesn't know, if this is supposed to be A times X or the variable called AX or AX. This is a very important distinction. So if I type this, it is just going to write AX. To show you what I'm getting at, what if I use that vertical bar? I will press this return arrow. I believe it was, there we go, math 3, vertical bar. What is AX if I tell you that X equals 3? Nothing. It's still AX, because the computer knows that X is 3, but it believes AX is something separate. If that's still confusing, watch what happens when I replace this with a variable and with a variable. Now, the calculator is going to know that this bold X is a variable that's equal to 3. It'll put a 3 here, and this will be 3 times A. Execute. You see how that works? So if you ever want to do something like AX squared, it's really helpful to actually use the variable X as opposed to the letter X. Just a little bit safer. A few more details. I will close the keyboard. I'll show you how to clear the screen. We go to Edit and Clear All. If you ever stored anything in a variable, you could fix that here. Otherwise, we clear all and OK. We are going to look at a few more functions from the Action and Transformation menu. We have Combine, and what Combine will do, it's almost easier to show you. We have X times X plus 3 plus, and then I'm going to pull up the keyboard and pull up this really nice fraction template. I'll put an X plus 1, down arrow, X plus 2, and I'll put a parenthesis on the right hand side. So what Combine does is it will take any rational expressions and combine them into a single reduced rational expression. That's why I had to put a rational expression here. When I press execute, you'll see that it forces this to also have a common rational denominator of X plus 2, and then it combines it all into a single expression. Collect will rearrange an expression with respect to a specific variable. This is also somewhat useful. Combine and collect are near each other. Let's say I had AX squared. Whoops, I guess I got a Z in there by mistake. AX squared plus BX plus CX minus 15. It will default to assuming you want it to collect X. So when I press execute, you'll notice it pulls the X's together. So there's a BX and a CX, it just lumped it as B plus C times X. That's what collect does. If you chose to collect based on a different variable, we could, for instance, say, we'll collect everything by B. And you'll see that it has anything times B, and then everything else is treated as a constant. Another really nice feature, I'll clear the screen again, another really nice feature under Action, actually under Interactive it may be easiest to find, define, we can give a function a name, tell it what the variable is, and fill out an expression. So let's say that I have a function called f, and x will be my variable, and I want it to be 10x plus 7. 10x plus 7. Press OK. So it will define f of x to be 10x plus 7, and you know that this worked when it says the word done. Now what am I going to do with that? Well, what I'm going to do, pull down here, put the cursor, and I'll back up. What's f of 2? In other words, if I plug a 2 in here, what's 10 times 2 plus 7 going to give me? And there we have it. We can do this again. We can drag it down. F of 5. One of my favorite things to do when introducing this function notation to students is, instead of a number, I will put in a word, just so that they see the behavior, because sometimes this looks like magic, and hopefully it becomes clear that I'm doing 10 times whatever goes in those parentheses plus 7 to follow this pattern. And when you get really good at this, we can even get super creative and put f of, let's say, -1. So you can start nesting functions. You can have functions with many different names. It all follows this syntax. Just define a function name, a variable, and that's the expression that represents that function. Let's try it again. I'm going to clear all, and I will go, you can also find define under command here. Define. So I'm going to define a new function. I'm going to call it temp, parentheses, and then I'll use t. Not that this is supposed to really mean anything. I'm just going to make it up 4 times, pull up those letters again, 4 times t minus 1. Execute. So now if I take the function called temp and put in a 3, it will compute it. So you can even use words that are meaningful. This can be really powerful to use this in the classroom. Let's see. We've mostly hit what I want to hit for this particular session. Quickly, I want to show you the interactive menu. Let's say I want to perform a calculation like a summation. What's great about this interactive menu is that any of these things you choose will prompt you for the parts. So if I want to do a summation, well, what's the expression I want to sum? Perhaps x squared. As my variable x varies from 1 to 10, let's say. Okay, incrementing by 1. It looks really nice and pretty. Now, it will look nice and pretty as long as this increment is 1. If you change it to an increment of 2 or 3 or something else, you'll notice things get just a little messier, and there's nothing wrong with that. That's just the way it is. I just wouldn't want you to wonder why your calculator was behaving that way. So there is your expression as x varies from 1 to 10 by 2's. And I find it very helpful to always think about it that way in my head, and then I never forget the syntax, because I know that it's an expression where x is my variable varying from 1 to 10 by 2's. Also, in the calculation menu, worth pointing out, we have modular arithmetic, which is remainder math, or what you might call clock math. We have functional maxes and mins, GCD and LCM. These are pretty straightforward. Oops, I should clear that. If I wanted to, for instance, calculate a GCD of 34, 12, and there you go. So at this point, oh, one more important thing I almost forgot. I would like to show you how to solve something. We have here an equation solver. Let me do it in an interactive menu just to make sure we have all the pieces. You can force it to solve numerically, which is what most non-CAS calculators will do. They'll get an approximation, but it will first try to solve it. If you leave this radio button checked, it will try to honestly solve this using algebraic methods. And I wanted to show you really quickly. Let's say we have ax squared plus bx plus c, and let's say that's equal to 0. Depending on what level of math you're familiar with, you'll potentially recognize this. This is a common thing that we would try to solve for, and I'd like to solve for x. And what it will do is actually try to get x by itself. It will try to get this to read x equals everything else on the right hand side of that equation. So if I press OK, you'll see the format here. It's not too surprising. Here's my equation and what I'd like to solve for. And this will look familiar to many people. It's essentially the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac over 2a. Here's the minus. Pressing this arrow gives me the plus. So if it can find multiple solutions, it will. And then perhaps, let's say you're trying to solve this for, you have a particular set of values for a, b, and c. If I back up, go to Math 3 and pull this bar down, I can actually say solve this if A is equal to 1, comma, B is equal to 3, comma, and C is equal to -5. Execute. Oh, I think I need curly brackets. Okay, so bear with me. I'm going to... This is what happens if you don't type it in the right order. Let me try to drag it in there. There we go. I'm going to go back here and delete this all. Let's see if that works a little better with curly brackets. And there we have it. It plugged them in, gave me a result. If I don't like that result, I can even highlight it, and this nice toolbar button will convert between the format that's exact format and a decimal approximation. I can highlight it again, I can toggle it back, highlight it and toggle it back. So really powerful stuff to be able to solve equations, to be able to input values. If you are going to input a single value, you don't need these curly braces. It's only if you're going to multiply or input several values that you would need those. And I think that is enough for now. Thanks for joining us, and I hope you check out our other videos.